Let's do an example with a big matrix. We have here a 5 by 5 matrix. We want to find the determinant of this matrix. By the way, as an aside, we can only find the determinant for square matrices. The determinant isn't defined for non-square matrices. So this is a 5 by 5 matrix. It's square. We're good to go. Okay. Now I know that I could expand along any row or column. Okay. I so if I have a choice, it's real nice to expand along a row or a column with lots of zeros. Now, the row with the most zeros is the last row. The column with the most zeros is the third column. Either choice would be good to expand along. All right. Let's go ahead and just go with the last row. Okay. So I'm going to expand along the last row. So 0 times the determinant of what's left. I don't really care about the determinant of what's left. I don't need to calculate that. Okay, that's a hideous 4 by 4 determinant, but I could skip it because whatever I get there, it's being multiplied by 0. Okay, so I'll just get 0. Next entry in the last row. Now this isn't 0, so I do have to worry about this. Okay, so I'm going to get a 1 and then determinant of what's left over. Okay, that's a 4 by 4. It is what it is. So I'm going to have the 1 and then the determinant of what's left over, which is after I cancel out that row and that column, I'd get, so after I cancel out that row and that column, I get 3, 0, 0, negative 1 for the first row, 3, 0, 0, negative 1, then 1, 0, negative 1, negative 3, 1, 0, negative 1, negative 3, 0, 0, negative 2, 0, 0, 0, negative 2, 0, and then 0, negative 1, negative 3, negative 2. 0, negative 1, negative 3, negative 2. Okay. Next entry in that last row is 0 again. So 0 times the determinant of whatever is the rest of the matrix is 0. And notice that's going to be the case for all of them. Get a 0, I get a 0, I get a 0. Okay. So those are going to be my cofactors. I only have to really worry about one 4 by 4. If I expand along, say, the first row, I'd have to worry about calculating two 4 by 4 determinants. One for the first entry, the first non-zero entry, one for the last non-zero entry, right? If I did the second row, I'd have to do 3, one for each of the non-zero entries in the row. So you want to, it's usually a good idea to expand along a row with as many zeros as you could find. Okay? Now we got to think about signs. So we had plus, minus, plus, minus, plus. So the first entry in the last row is positive. And so then I'll go positive, negative, positive, negative, positive. Those are going to be the signs that go in front. So positive, negative, positive, negative, positive. Okay? All right. So now I'm just going to have that negative 1, and now I could focus on what the determinant of this is. So I've got to do another determinant. This is a 4 by 4 determinant. All right. Again, I could choose whatever row or column of this 4 by 4 matrix I want to expand along. So I could expand along the first row, but I've got 2 zeros and 2 non-zero entries. So let's see where we have the most zeros. So I have 3 zeros in the third row. I also have 3 zeros in the second column. I think I'm going to expand along the second column just because I have a smaller number. Smaller numbers are also nice to work with. Okay, so I'm going to expand along the second column. So if I expand along the second column, notice the first 3 are just zeros, so the cofactor expansion for those are just 0. So 0, 0, 0. And then the last one is negative 1, And then if I cancel out the row and the column, the determinant of what's left, I get 3, 0, negative 1, 1, negative 1, negative 3, 0, negative 2, 0. So the determinant of 3, 0, negative 1, 1, negative 1, negative 3, 0, negative 2, 0. And so by finding the row or the column with as many zeros as possible, I've again saved myself a lot of work. All right. Now I still have to think about the signs of these. Okay. So I'm in the second column here. So first entry right here, that's a plus, minus, plus, minus, plus. So in the second row, I'm sorry, the second column, I go minus, plus, minus, plus. Okay. That's how it would work in that checkerboard pattern. So minus, plus, minus, plus. Okay. We're almost there. I've still got a 3 by 3 left. Got negative 1. I've got a bunch of zeros. I'm just going to leave them off. Then I have negative 1 again. And now let's take the determinant of the 3 by 3. Again, look for what's easiest. I notice I have a row of 2 zeros, only one element isn't a 0. So I'm going to do that. Okay. Make that a little bigger. There we go. Okay. So if I expand along the third row, I'm going to get 0. I don't have to worry about the determinant of whatever matrix is left over, because again, 0 times the determinant of the matrix that's left is just going to be 0, whatever that determinant is. Anything times 0 is 0. That's why we like those zeros. Okay, so 0, negative 2. Imagine canceling out the row and column. I'm left with 3, negative 1, 1, negative 3. So negative 2. And then I take the determinant of what's left over after canceling out the row and the column. If that negative 2's in, I get 3, 1, negative 1, negative 3. Okay, and then the final entry in that last row is a 0 again. What about signs? First entry is always positive, first row, first column, so I could base everything else off that. So let's get down to the row I'm in. Positive, negative. So the first entry in the row I'm in has a plus in front of it, then a minus, then a plus. Okay, so plus, minus, plus. So plus, I won't actually write it because it's not necessary, but minus, plus. Okay, so I get negative 1, negative 1, the zeros go away, and negative, negative 2 is a positive 2. And then I just have this 2 by 2 determinant, and we're home free because 2 by 2s are super easy. I get 3 times negative 3 is negative 9. Negative 1 times 1 is negative 1. So negative 9 minus negative 1 is negative 8, right? That's negative 9 plus 1, negative 8. Okay. And so I get negative 1 times negative 1 times 2 times negative 8. That's 3 negatives, so the answer will be negative. And 1, 1, 2, 8, if I multiply those together, I get 16. So negative 16 is the determinant of this 5 by 5 matrix.